much for joining. And to be honest, okay, so before we start, I need to mention a few things. First of all, it is like a rehearsal of my talk. I will do it together with Evgeny Borisov. That's why he will manage, Evgeny will sort out the part which is about Spring Cloud capabilities, and I will talk about cloud part. So that's why, as you may see, there are two names here, Evgeny Borisov and Alex Barmin. That exact Evgeny Borisov. So first of all, as ordinary, I'd like to start with this exact slide. This is everything I'm talking about today is my personal opinion and my personal experience. So if you're building your production solution based on it, just to double check, maybe you have different conditions. That's why you will get different results. Okay, so I suppose we're ready to start. As it was said, I'm Alex, Chief Engineer, Cloud Architect Associate, and follow me on Twitter and on GitHub. Okay, so this is my dog. Her name is Bulka. She is amazing. So let's do not waste the time. So what I'm going to talk about today. Today, I'd like to talk about building Docker images for Spring Boot application, because if we're going to clouds, Docker images is our main building block. Next, we'll take a look into the Spring Boot actuator, what capabilities it provides us, how it helps us dealing with cloud services, and so on. Next, we will start our microservice in Docker, in Kubernetes, and if we have time, in ECS as well. Okay, let's start. So this is the application I am going to present to you today. Quite simple and straightforward application which receives a REST request, and like about challenges. Challenges is like a test. Oh, have you seen? I suppose you have already seen number of tests when you have to choose from one of, for example, 4 different answers, and only one of these answers is correct. So what I have here, I have a challenges provider. This is like a API gateway application, and this API gateway application that does not know anything about challenges itself. That's why this service delegates to a particular service. If we're speaking about cloud, we ordinarily have a distributed environment. That's why we need to have a service discovery, and every service, as soon as it starts, should be registered in service discovery server, of course. If you had an opportunity to deal with Evrika, here we're talking about Evrika. Well, and in case if any particular end user would like to get a challenges, what exactly he will do? He will send a request to challenge provider. Challenge provider will ask whether particular providers are registered in Evrika and request some data from them. And this is my favorite. Like quote: "Talk is cheap. Show me the code." Let's in this case, let's move to the code. First of all, guys, please confirm you see my IntelliJ. Yep, you should see it.
Yes.
Yes.
Yeah, great. So what I have here, as you may see, it is multimodal Gradle project. What exactly is included here? So quite simple and straightforward thing. I'm adding a support for Lombok, Spring Boot Starter, and Test for all my subprojects. I use JUnit 5 and Java 17. No worries if you did not have an opportunity to deal with it, because I will not focus on Java features today. So speaking about service discovery is really simple. The one single dependency I need to add is Spring, Cloud Starter, Netflix, Evrika server, and that's all. To be honestly, right? Because more likely you're already aware how it works. In order to start service discovery, you need to do only one single thing: create a Java class and put enable Evrika server annotation on the top of it. It will be started as ordinary. No special things will happen. So service discovery started. It is available. And just a few things you should be aware of is to these things. It is, I suppose it's a good idea, do not register service registry in service registry, and service registry should not ask service registry regarding self-registration. So just to avoid unnecessary registrations. What else do I have? I have a challenges provider. This is the main worker of my application. Of course, it is simple, straightforward, and consists of one single thing. It is a REST controller which receives requests. Requests are simple things. It is just a map, like a discipline on the left side, number of questions to generate on the right hand side, and next this request is sent to provider, and provider do very simple thing. It asks another provider, service URI provider, where should I send request in order to get data? And as soon as URL is generated, it sends request using REST template. I written this code in this simple manner. In this simple manner by design. The main idea is to highlight that we could communicate with external services using very simple things like REST template. Of course, we could use Fin client and so on, but what I'd like to demonstrate is just very basic communication. So what else is here? Of course, the most interesting piece for us is provider. Provider is a simple interface which has a couple of implementations. For example, I can use service discovery client in order to get information about available instances of a particular service, and next choose an instance to send requests to. And second implementation is stupidly simple. It just returns string based on very simple pattern. Simple, quite simple application. Really, I think it's obvious. Okay, so you notice that this application does nothing on its own. It delegates everything to providers. My providers are also simple and stupid. So this is provider. As you may see, it has nothing except this main class. And all the magic is stored here in the provider base. Oops. Provider base is a Spring Boot starter. I decided if I use Spring Boot and need to create a few providers, it's better to write some magic thing like starter, because why not? I can do it. So in order to start with starter, what I should do? Of course, I need to create a resource. I need to create a Spring Factories spring.factories file in meta-inf directory. And here, if I'd like some of my configuration to be imported during the startup of the application, I just need to enumerate it here. So my provider configuration is imported during startup of the application. So what annotations I have on the top of it? Simple configuration and component scan, which says that everything you have in subsequent and internal packages should be scanned and added to your application context. So what I have here, of course, here I have challenges resource. Again, what it does, it's process some requests from external clients and just return challenges. Challenge, as I said at the very beginning, it's a question and collection of answers. Answer is a string with answer and indicator whether it's correct or not. Okay, so I have finally done with all the necessary preparations, and while we're talking, I will start all my applications. So 4 applications are here. Let me demonstrate. All of them are working as expected. So the first thing I need to show is, of course, how Service Discovery managed to find all my applications. It is not a complicated thing. What I need to do is open my browser and to go to localhost 8080 So I see Evrika has been started and 3 instances are registered here. So 3 application: challenges provider, which is entry point, challenges provider for history, provider for math. Simple and stupid. Okay, let's try to send requests to these applications. What I have, I of course have some presets. So I'm sending a request, I'm getting a response, application is working as expected. This is all I have for preparation. Let's get started and go ahead and go to deploy our applications into cloud. Right? Right. Okay. Denise, I will move you to another monitor. Sorry. As I said at the very beginning, Docker images are our main building blocks. And on the left-hand side, you can see an ordinary Docker file, right? Denise, I see you're looking at my slides and thinking about something. So what do you think about?
No, because I'm just trying like to compare it with .NET, you know, because I'm from .NET world. Just consider how I would do it in .NET. So
yeah, you will definitely can do it in .NET.
I believe so. Yeah.
Yeah, okay, so if you have a Docker file like this, more likely your Docker image will consist of the following pieces. On the very low level, you will have an Alpine Linux, because my Docker image is generated on the top of OpenJDK, a JDK Alpine. Next, JDK, of course, because my Docker image is, in order to run Java, I need to have JDK. What's next? Next piece is my fat jar, because I'm dealing with Spring Boot. Spring ordinary generates fat jar, and as you may see, it takes, well, at least half of my Docker image size. Not precisely, but fair enough. Let's go deeper and try to take a look what's inside my jar file. Well, if you remember, or at least had an opportunity to deal with Spring, you will know that a significant amount of Spring is just dependencies, which never changes, like Spring, Hibernate, Apache Commons, Guava, Jackson, and all mappers, marshallers, and all that stuff. Next part is your own dependencies, which is crucial for your particular one single microservice. It can be dependencies to other common modules, for example. Yeah, it's useful, and these dependencies are changed, but not so often. And last piece of your application or last piece of your jar is your own code. To be honest, it will definitely take a very small piece. And interestingly, that these dependencies provided by Spring and dependencies from your module is almost the same every time, every build. You build a new version of your application, more likely you are not changing Spring version every time. What you changes is this piece, which is on the top, right? Of course. So let's try to build Docker images. So what I have console. So have you ever heard this story that if you're dealing with microservices, you need to have automation? This is my automation. It is written in Bash. So before we start, what I'd like to do, I'd like to start my my shell script. And this shell script will start doing the magic. And while it does the magic, I will explain what's happening there. Of course, right now, I'm just building my Docker images in a very naive way. So what I'm doing, I'm building my application, and next, using Docker build, I execute the build. Right. What's inside my Docker file? My Docker file is simple, as I said. It is derived from Coreta, Coreta from Amazon 17. It just adds my jar file and declares entry point. Simple, quite simple, nothing special. But let's take a closer look. What is exactly inside my Docker image? So as you may see, it did not take a lot of time because all the dependencies has already been downloaded before, so it does not take much time. So what I'm doing next, I'd like to take a look into my Docker image. That's why I use dive program. It is a simple console tool which allows me to take a look what is the content of my Docker file. Right? Guys, are you still here with me? Raise your hand if you are here. Yeah, okay, so at least a few people are here. Okay, so Let's take a look into my Docker image. So on the very top level, this is the basic piece of my image, which is kind of Linux. More likely it is AMI. Next piece is my JDK. This is files which were introduced by Coretta, by guys from Amazon. So nothing interesting. And what's next? It is 41 megabytes of my own jar file. So what does it actually mean? It means that every time I release a new version of my Docker image, every time I need to upload 41 megabytes to, for example, Docker Hub or Elastic Registry or anything else. So I have to pay for 41 megabyte every time. So, and the second problem is that this Docker file is not really smart. It does not provide my application with any information regarding available memory, available CPUs, and so on. So is there any way to build Docker images in a smarter way? Of course, yes. And here, if we're speaking about, Spring is using Spring Boot Maven and Gradle plugins. And these Spring Boot Maven and Gradle plugins are quite clever. While I'm talking, if you don't mind, I will start the build and explain what's happening. So there is an initiative called Build Packs. Build Packs is a thing which is a collection of builders. This collection of builders allows us to build almost any kind of application, whether it's JavaScript application, Java or .NET application, in a better way. So idea is to build a Docker image using predefined set of best practices and predefined set of very useful helpers. Like speaking about Java, if I'm building a Docker image with a build pack, it will build not only my Java application, but also introduce quite smart starting script, which provide my Java application with some things like information about available memory with good starting good entry points with flags and so on. Let's take a look into Docker container, which is built by Buildpack. So if you don't mind, before we move forward, I will show what exactly I did in order to build this Buildpack. To be honest, nothing. Clean boot build image.
Alex, sorry, can I interrupt you
Yes.
for a minute and ask the question from chat? Vadim Kovalkov asking, could you please scan your image with Gripe? I don't know what Gripe is actually, but
I do not have Gripe right now.
What? By the way, what is it?
But Vadim, what is it? Yeah, feel free to unmute and join the discussion.
The Gripe had been built by Anchor, and it helps you to scan for security vulnerabilities, and you can find the way how to get your application more secured. I mean, probably have some vulnerabilities due to the fact that you are using kind of legacy versions and something like that. So it could be useful. Moreover, you can add it to your pipeline, and you can bridge gaps in some security moments. It's really useful, and you can set up it so easily as you set up the dive. And yeah.
Thank you. Thank you. Yeah, thank you very much. Well, to be honest, I'd like to demonstrate that using build packs is also not quite a good approach, because it has not very useful basic image. So if you don't mind, I will demonstrate it a bit later. And well, time is going. I need to move forward. Sorry. Okay, in order to configure my build image, what I did, to be honest, almost nothing. So if you take a look into my build Gradle file, it is just a configuration which said what's the name of, what is the tag of Docker image is built. So let's take a look into this Docker image. So I need to copy and go deeper into the dive hub. So ready, steady, go. Please start. Yeah, it's here. Oop. So basic. Next, like additional sources list, what's next, certificates and so on, useful configuration. Next, configuration for like groups. What's next? It is helpers. What's next is here. Well, we're moving to the Java, additional security helpers. What's next? Additional like configuration. What's next? Next piece is Java. Buildsoft Liberica. What's next? Class pass and so on. Not really useful, but what's next? Next piece is, as you may see, it is just a collection of libraries which or dependencies which are ordinarily provided by Spring. Spring Boot, Spring Cloud, Spring so on. So they are in a separate layer. What's next? Next piece is a Next is also a useful thing. It is just a Spring Boot loader. Spring Boot loader is a starting point for almost any Spring Boot application, which allows you to start Spring Boot application from jar, because jar, which is built by Spring Boot, is a bit different jar. That's why it's necessary to have starter in order to run, for example, all the dependencies in order to run Tomcat and deploy your application inside and run your application inside. So this is again in a separate layer. What's next? Next piece of 5.6 kilobytes is my application. This is, to be honest, all I written is here, not 41 megabytes as previously, but only 5 kilobytes. And what's next? Just additional things. Okay, so looks like if I release my application, if I try to release my Docker image one more time, how many data I will need to send into my Docker registry next time? Looks like something like 3 megabytes, no more. I suppose it's much better, right? Right. However, more likely we're not using our applications independently. And what we're using ordinarily, we're using, if we're speaking about Docker, we can use Docker Compose in order to run many applications at once. So if you're familiar with Docker Compose, more likely you know that applications are starting in a completely random way. But what we'd like to have in this situation, we'd like to have our service discovery server to be started before all other applications, just because in order to avoid situations like this, right? Right. And what we'd like to have something like this. So while service discovery is starting, all other services are waiting. And as soon as it is ready, our providers can start can start running and register inside it successfully. Well, there is a few things which could help us understand that application is up and running in order to receive our requests. It is quite simple thing called health check. Health check from, for example, Kubernetes point of view can be split into two different checks, two different probes. Liveness check, which says that application is running but not ready to accept our requests and process it successfully. And second thing is readiness check, which says that, okay, our application is up and running, can allow to accept our request and process it. Unfortunately, Docker does not support both of them, but nevertheless, we can use it. That's why I said that images built with build pack are not the best images we have. Let's take a look into the very basic Docker Compose file. And before we start, I will check that nothing is started. And Docker Compose, I will execute Docker Compose up. So as you may see, not all the services are started simultaneously. If I execute Docker PS in the separate console, what I will see? I will see that my application, Service Discovery, is starting right now. Well, before we move forward, let's take a look into the Docker Compose file, which I just demonstrated. This Docker Compose file, come on, please work. is looks a bit complicated, but let me explain. It consists of 4 services, 2 providers, main application and service discovery, and all other applications are waiting until service discovery starts. How is it achieved? It is achieved using health check probe, which is provided by Docker. So what do we need in order to understand that our application is up and running? We need to ask the application, dear application, are you ready to proceed? Yes, yes. If we're speaking about Spring, what we have? We have Spring Boot Actuator. Actuator, it is a Spring Boot starter, which provides you with all these monitoring and capabilities for exporting these like metrics and probes to external systems like, for example, Docker, Kubernetes, or even to be honest, to almost anything. So how to understand that our application is up and running? The easiest way to do it is to use some stupid tool like curl. And I know that my application inside container is listening for port 8888. And if this curl returns has a return code 200, that means that my application is up and running. So just I see a couple of questions from Vadim. Why do you not choose Jeep to build image? Because build packs are built in Spring Boot. This is the main reason. Yes, I know that it's possible to use Jeep, but for this particular demonstration, I decided to use build packs. What kind of health checks have you added to readiness group? Nothing. So it is just a default. So what is there? I did not add anything else.
I'm sorry, and what is the difference on this case with the liveness check? I mean, so if you have a liveness check, you've discussed it. Yeah, it's about the state of does our application up or down, and the readiness state is about are we ready to accept the traffic? And in this case, so we have no difference at all.
Yes, in this particular case, we do not have any difference at all, but we can add additional check to check whether, for example, for example, caches are populated with all the necessary data. We can add additional checks to to check, for example, to indicate that not only caches, but like necessary dependencies are also ready, like the schema of database is updated, because in this case, application can be started but not ready to process requests.
Thank you. I get it.
Yeah. Okay, so that's a very good question. Thank you very much, because it's like a dry run of my talk. I will definitely tell about it. Well, let's move on. So what I have here, I have a health check, and I have a depends on dependent services. So what it does ordinary, if I add a depends on and name of the service this particular container is depending on, it will start my Docker containers in a proper order, like it depends on service discovery. That's why start service discovery, and the next challenges provider, right? However, it is not enough. I'd like to have a more complicated, more sophisticated check that my challenges provider should start only if service discovery is up and running. That's why I add a condition here. So if I take a look into my console, you may see everything is working. These services do not have health checks, but this service is healthy. If I get back to my previous console where my service was started, okay, so I will see that first service which was started from the very beginning is service discovery, and only after that all other services are starting. Okay, so what I'm doing next, just to check that everything is working. So as you may see, application is working as is. So let's move forward and try to start. Oops, Docker PS, Docker Compose app. Let's try to use images which were built by Spring Boot plugin. Images which were built by Spring Boot plugin has a different label. I called them OCI, Open Container Initiative. And as you may see, there is an interesting situation. There is no health check. Let me explain the reason. Docker PS, Docker exec minus it bin bash. So I'm inside my Docker container. Ping, no ping. Curl, no curl. Wget, no wget. I have nothing to check whether my application is up and running, just because it uses a very, very tiny basic image, and it will be necessary to build a new build pack in order to have an opportunity to include all additional tools into my Docker image. That's a pity. Okay, so there should be a way to do it properly. So my next idea is to build a Docker image, which is layered, but customizable, of course. So what I will do in order to do it, of course, you have already seen that here I have the third command, a third shell file. It is called app images layer. I will start it, app images layer. And while it starts, I'd like to, oops, sorry. I'm going too quick, sorry. Whew.
Sorry, by the way, what's the wonderful tool like Far on the Nordson Commander is this?
Midnight Commander.
Midnight Commander, okay.
Yeah.
I will take a note. Yeah, thank you so much.
Mm-hmm. Console is still the better way of doing programming. Yeah. So what do I have here? I have a challenges provider.jar. How to start it? Java-jar challenges provider, right? Right. But what if I try to take a look into layers? Jar modem layer 2 challenges provider.jar. Layer. I ordinarily understand how it is called. Layer tools. Layer tools. Jar model layer tools. Yeah. Java has an amazing feature. It allows you to split your jar file into layers. What does it mean? So, as you may see, there is almost nothing. One jar file of 39 megabytes. And if I execute extract java.jar model layer tool extract, so what will I have? I will have here, I have a number of directories. Application dependencies, snapshot dependencies, Spring Boot loader, and every folder contains dependencies which belong to a particular layer of your application. If I take a look into the dependencies, what will I see? I will see all the dependencies which belong to the Spring application, right? Right. If I take a look into the snapshot dependencies, nothing for now because I do not have snapshot dependencies in my class path. Spring Boot loader, what's it? It is a piece of Spring Boot which allows me to start my application. Jar launcher.class is the entry point here. And what else? Also, I have an application directory, and this application directory contains a few magic files. The first magic file is layers.jar, and it says what exactly should be included into a particular layer of my application. This is layers IDX is just a configuration of what to include, and this is a file which says what should be included into the class path, just saying what is there. So, and classes is only, if you don't mind, I will show them this way, 3. So this is the content of what? This is the content of my application. This is only classes I written, right? Right. Yeah, I see the. I think you're still following me. So what I did, I split my I built my Java my jar file, and next I decided to split it into folders. Every folder contains separate set of dependencies. Like application is my own dependencies, Spring Boot dependencies are in separate folder, Spring Boot launcher is in the separate folder. Why do I need it? And now I'm ready to start runner, not runner, but script which builds Docker images. And let's take a look into my Docker file. This is my Docker file. So as you may see, it is pretty simple and straightforward. It is derived from it is built on the top of Amazon Carrieta. And what's next? It adds dependencies layer by layer. If you're aware about Docker, you know that every command creates a new Docker layer. And if a layer is already available in your Docker registry, it will not be sent again. That's why it is added in that direct order. So if I do not use new version of Spring, more likely my Spring Boot loader will not be changed. My Spring Boot is quite stable thing. I do not need to send it every time. Snapshot dependencies, more likely they will not be changed, but still. And this is the piece which will be changed if necessary. So as a result, I have much more this is the thing which allow me to send only a very small piece of my Docker image into the registry if something is changed. So as you may see, everything has been built. And using dive, I can take a look into my Docker image again. You may see it is tiny, and what else? It is tiny, first of all, and it is much more customizable in comparison with the image built by build packs. So what else? So as you may see, 164 megabytes for what? For Linux, almost 300 megabytes for Java, and this is my application. This is Spring Loader, this is Spring dependencies, and only 5 kilobytes of data is what I actually written. And next time when I will upload my Docker image into the registry, what amount of data I should load? Only 5 kilobytes. Isn't it a good idea? Isn't it a good achievement? Yeah, I see the comment from Alexander that curl is a good thing. Curl is a good thing, and I could install it right during a demo. Yes, that's correct. However, yes, I could log into my Docker container, install it using YAML, for example. Yes, I can do it. But do I need to do it every time if I, for example, run in hundreds of containers? I don't think it's a good idea. And well, as ordinary, there is a trade-off. You can build your Docker image on your own. That's true, and build it in a relatively good way, like this. Or, of course, you can use build pack and rely on build packs which were built by other people. These build packs are also great. I cannot say that they are not good. You can build your own build pack and add all the necessary dependencies into it, like curl, ping, wget, and so on. However, it is not so obvious. This is the main reason why, for this particular example, I decided to reject build packs. Just because if I'm dealing with my own Docker file, I have much more flexibility. And as it was said by Vadim, we could get some performance, for example, improvement if we add additional capabilities like Spring Indexer. So this trade-off. We on the one hand, on the left, on the one hand, we can try to get rid of Docker file. On the other hand, we can try to get more flexibility in what we're building. Okay, Denis, how much time do I have?
I believe that the counter question, are we going to deploy this to AWS for now or what? What are you going to show us?
So very simple things I wanted to show, just to adding additional metrics to Actuator, exporting these metrics to Prometheus, and deploying to Kubernetes. I do not think we will have enough time to deploy it to EKS.
Right, I see. So actually we have about 15 minutes. This is a scheduled time, I believe. But I don't know if there are any questions. So I believe we can move on, and if there are any questions, we will discuss it.
Yeah, in the very same way during our talks, right?
Yep.
Okay, so let's move on. So what else? The next step, of course, is to run our application and using Docker Compose. What I'm doing, just checking Docker PS that nothing is running, and Docker Compose Alp will start my application. And if I take a look into another Docker Compose file, you may notice that it consists only of 3 services: challenges provider, provider for math, and for history. Why I'm not doing? Why I am not adding? What I should add? I should add the service discovery. I'm not adding it because service discovery in this case is provided by Docker, and there is no need to do it. I'm switching to another implementation of my URL provider by providing a provider type environment variable. So if we take a look here, service URL provider has a couple of implementations. All of them are switched on using conditional on property annotation, and this, the simplest one, is working. Then provider type is equal to Docker. So is it working? Let me check. Of course it works, but I'd like to demonstrate to you that it works. Works. Okay, so I have Actuator, and let's try to send requests to this Actuator endpoint. What does it take to me? The very simple thing it can provide me back is health of my application, whether it's up and running, or for example, my application does not have enough disk space, or maybe it is not connected to some message queue, or database is on maintenance right now. Also, I can ask my Actuator to provide information about readiness of my application, like it is up, or liveness my application, again, it is up. And of course, I can create my own probe. And here I'd like to demonstrate how easily you can do it. So, well, you noticed twice it was okay, but now it is not okay. So in order to make your own probe, the one of 2 things you need to do is to implement your own health indicator. This is my health indicator. Just take a random number from 0 to 2, and if number is 2, it says that due to the invalid phase of moon, the application is not working. So it is not enough as ordinary. If you're dealing with Spring, you should be aware that it does a lot of magic, but more likely you need to include something into your application.properties. And first of all, in order to have probes, what I need to do, I need to have my probes enabled. And what I'm doing next, I'm including my custom probe into my custom group of probes. So let's get back and scroll here. So when I ask for health of my application, it returns 3 groups of probes: liveness, readiness, and my custom group. And of course, here I can ask my custom group for additional information. Surprisingly, this name custom is generated by Spring. So it takes a look into the name of the bin. In this case, it will be custom from the lowercase c health indicator. It just get rid of health indicator, and name of this probe is custom. Surprisingly. Okay, this is a piece of automagic. Another thing which is quite useful is metrics. So if you're running your application and if you have a number of containers, you're more likely to be aware of not only health of this application, but also about some internal details. For example, how many documents were processed? How many disk space do I have? How many, I don't know, JVM threads are in the live state right now? So if you have a metric, if you have an actuator, you can expose the metrics endpoint as well. In order to do it, don't forget to include it into the web exposure, include parameter metrics are here. And of course, you can do your own metric. So for example, I can use any metric which is available out of the box, like number of CPUs. And if I'd like to have my own metric, the one single thing I need to do, this is true in this case. One single thing, I'm adding a bin which of type matter binder. This matter binder bin is responsible for getting something. Like in this case, it is a measurement of challenges count, which provides some value from this lambda and some unit and description. For example, you can measure using this, you can use actuator for exposing metrics. And what other metrics are available? Of course, you can use metrics like this, like measurements. It is possible to have counters, it is possible to have timers, and so on. So many things which allows you to collect information about your application. Quite useful stuff. And of course, if you're using something like a Prometheus, you can ask your actuator in order to export metrics in the Prometheus way. So as you may see, a lot of metrics are already available, and of course, metric which I introduced is also here. Whew. Let's try to deploy my application into the Kubernetes. To be honest, it is not not so complicated as it can be. My application, I'm going to deploy my application in 3 parts. First of all, I need to configure Kubernetes, my local Kubernetes. Okay, Docker PS, Docker compose down. Please switch off everything. Whew. Docker PS, nothing is here. Kubernetes, please configure correctly. And what I need to do? First of all, of course, in order to deploy my application, I need to have YAML file, because if you're dealing with Kubernetes, you are dealing with many YAML files. So the main deployment unit is deployment. This is deployment. This deployment deploys 3 replicas of my services, 1 replica per service, right? Right. So what I'm deploying: challenges provider, provider for math, provider for history. If I take a look into amazing tool called Lens, it will show that in my Kubernetes deployment, I have 3 pods, 3 deployments, and all my containers are quite healthy. And this information is provided by these liveness and readiness probes. So this is the quite simple way of configuring liveness and readiness probe in Kubernetes. So if I send a request to my application, what will I get? Again, previously it was working, but here, okay, it does not work. Why? Because I have not created services. Service is a quite useful thing which allow my application to be available for the external world or make my application available for other applications. So my next step in this case is to deploy services. I have created shell scripts for almost everything because it is much easier than writing kubectl, apply, and so on. Get service. So as you may see, I deployed a load balancer inside my Kubernetes cluster of 1 single node. And let's try to send the request once again. I'm sending a request that in this case application responds correctly. However, no, application responds, but it responds with status 500. Why? Because it does not have access. Let's take a look into the lens, into my pod, what's going wrong with my application, just because it says that dependent services are not available, provider for MAF is not available. So what should I do? I should deploy services for other applications as well. And next, everything should work. Come on, please work. Oops. Yes, everything is working. So what's in my services? Just simple Kubernetes YAMLs, which says that for these internal services like providers, they should not be available for external world, and challenger service, which is entry point, it should be available for the external world. Okay, let's move on. I think that's almost all for Kubernetes. Kubernetes was simple. In order to deploy our services into Elastic Container Services, what do we need to have? VPC, subnets, Internet Gateway, routing table, security groups, IAM, application load balancer, listener, target group, and Elastic Container Registry, and Elastic Container Service on the top of it. I will not demonstrate how exactly I created all the necessary artifacts, but I will go shortly across all of them, which are required to deploy application to the cloud. So first of all, there's a cloud formation stack to create all the resources. Next, I have a script which push all the Docker images to Elastic Container Registry. And 3 things which are left, I will demonstrate very, very shortly. I hope we will manage to do it. Just bear with me for a few more minutes. I will demonstrate.
Yes, meanwhile, if you have some questions to Alex, please feel free to put it into the chat, because we have 5 minutes left and this is like a last chance to ask.
No worries, no worries. I will share all my code. So if
actually, that was I was going to ask, because it's really interesting. I would like to to dive a bit deeper to your project. Right.
Yeah. Okay. So this is my Elastic Container Service. It's like a Docker and cloud. Before moving forward, what I need to do, I need to create task definitions. In order to create task definitions, I have a few. If you don't mind, I will start creating tasks and switch to IntelliJ. In order to create tasks, I need to, of course, there are a few options. I can first of all upload my task definition to S3 and next execute, for example, CloudFormation spec in order to run them. And of course, I can use CLI in order to create task definition from files which are on my local machine. So this is the script which creates task definition for everything, and for every task there is a special JSON file which says that this is the name of my task definition, this is the container I'm going to use. Like container is built on the top of image which I taken from my Elastic Container Registry. I'm exposing port 8080, adding some environment variables, configuring logs, and for my application I need to have at least half gigabyte of memory, and this is the collection of specification for everything. So if I go back to my console, what I will see that definitions are here, but it is not enough in order to start my application. What I need to do next, I need to create services, because services are building blocks of my application. And in order to create services, it is not as simple as it seems. So this is the bash script which creates services in cloud. I was a bit surprised that this is almost a, let's say, almost a single way to create services properly, because yes, of course, you can try to write this in cloud formation, but even official examples from AWS are about console or using, for example, Python scripts with Cloud Development Kit. So it is not so simple as it was with Kubernetes and as it was with Docker, but it's still possible. So this is like a working instruction or working example. So what is here? Here I have a cluster. Cluster has services, and every service has a collection of containers, and every container has all I need. So I started my Java in cloud. 2 minutes left.
You did it.
Yeah, I did it.
Congratulations.
Yeah.
Right. So.
Yeah, I see the note from Alexander
Yes.
that I can try code deploy. Yeah, I know. If you take a look into my examples, there are a few more with code commit, code deploy, and so on. Code deploy is also not a simple way of doing it, to be honest, because in this case, I will need to write more YAML files. But yes, that also works. Thank you. Hooray!
Right.
That
was yeah, this was really interesting. You know.
Oh, I forget to put link to my GitHub repository. If you don't mind, I will do it right now.
It's a good idea, I believe.
Uh-huh.
And by the way, please, could you please like share the presentation with me? I will include it to the follow-up.
Yes, will do.
Great. So guys, today, later or tomorrow, I will send a follow-up email with all the materials included. Thank you very much for attending the session. Alex, a special thanks for you for the great presentation. So I believe your presentation, sorry, by the way, where you will going to present this the second time?
Jugru meetup.
Okay.
Yeah, Evgeny will tell about capabilities of Spring Boot, Spring Cloud. I will tell about deployment to everything.
Sounds good. Okay, so good luck then.
Thank you very much.
Thank you, guys, and have a good day. See you.
Thanks.
Have a nice day.
It was
Bye-bye.
really interesting.